This is measuring segments, day 2. So this worksheet consists of midpoints and segment bisectors. It also has midpoint formula and distance formula, along with finding the other endpoint using the midpoint formula. Okay, so number 1, it says a line JK bisects segment LM at point J. We need to find JM if LJ is 23 centimeters. So let's draw it out. We have segment LM. Segment LM is bisected, meaning it's cut in half by line JK at point J. So we have a line JK that bisects segment LM and splits it in half. That means that LJ, segment LJ is congruent to segment JM. They're going to be equal because their LM is split in half. We know that LJ is 23. Since LJ is 23, we know that JM is also going to be 23. Right, we know that LJ is going to equal JM, and LJ is 23. Okay, and that's going to be 23 centimeters. So centimeters. Okay, that's number 1. Okay, number 2. We have line WX bisects segment YZ. So let's put a Y and a Z. Line WX bisects means it splits it in half at point W. So this is point W. Here is X. We know that we need to find YZ if WZ is 9 5/8. And we know that 9 5/8 is really going to be 8 times 9 is 72. 72 plus 5, 77. So that's really 77 over 8. So I'm just going to use that instead of our mixed fraction here. So 77 over 8. Since we have a bisector, we know WZ is going to be congruent to WY. Because it bisects, it splits in half, so those two segments are the same length. So YW is also going to be 77 over 8. We know that we can use segment addition here. YZ is going to equal YW plus WZ. So YZ is going to be 77 over 8 plus 77 over 8. That's going to give us 154 over 8 over 8. If we reduce that, though, it's going to be 77 over 4. So our units there are inches, so 74. Okay, 77 over 4 inches. Okay, let's do another one. Number 3. Point F bisects segment GH, so we have a segment GH. It's bisected by point F. So that means point F is in the middle such that GF and FH are congruent. Find GH, which is the whole thing, if GF is 14 and 7/12. So 14 and 7/12, 12 times 14 is 144 plus 12 is 156 plus 12 is 168. So 168, 175 over 12. So this one's 175 over 12. Oh, sorry. GF is 175 over 12. Then FH is also 175 over 12. We want to find GH, so we're going to simply add them together. So GH is going to equal 175 divided by 12 plus. That's going to be 350 over 12, which is going to be 175 over 6, and our units are feet. The last one here. Point R bisects segment ST. So point R is going to cut ST in half. Okay. That means that SR is going to be congruent. Segment SR is going to be congruent to segment RT. We want to find RT. We know that ST is 16.9. So this piece here is 16.9. We know that SR equals RT. We know that the big one ST is going to equal SR plus RT. But we know that SR equals RT. So instead of our SR here, we can substitute in. So ST is going to be 2SR. I'm sorry, 2RT. Sorry, it's going to be RT plus RT, which gets us 2RT. When we know we know ST is 16.9, so 16.9 equals 2 times RT, so we simply divide by 2. So we get RT equals, what's that, 8.45, right? 16 divided by 2 is 8. 0.9 divided by 2 is 0.45, so that should be 8.45. And that's going to be meters. Okay, that's going to be RT. Okay, you're just taking 16.9 divided by 2, right? 16.9 divided by 2. 16.9 divided by 2. You don't have to write the long way out. Right? 16.9 divided by 2 is 8.45. So this is 8.45, that's 8.45. All right, in the diagram, M is the midpoint of the segment, find the indicated length. So M is the midpoint. We got to find the length of MQ. We're going to need to use the midpoint. Okay. So here, M is the midpoint. That means PM is equal to MQ. So we know 4x minus 1 equals 12x minus 17. Subtract 4x. So negative 1 is going to equal 8x minus 17. We add 17 to both sides. 16 equals 8x. So we're going to get x equals 2. What we're trying to solve for is MQ. MQ is this piece right here. We know that MQ equals 12x minus 17. So we're going to substitute it in. That's 12 times 2 minus 17. 24 minus 17 is 7. If we want to check our answer to make sure we're right, we can plug it into the other one. 4 times 2 is 8. 8 minus 1 is 7. So 7 and 7, we're good. Let's do number 6. Okay. So we're on number 6. Again, M is the midpoint of UV. Okay, so we know UM equals MV. UM is 21x minus 13. MV is 10x plus 31. Okay, subtract 10x from both sides. It's 11x minus 13 equals 31. We add 13. We get 11x equals 44 divided by 11. X equals 4. We want to find UV, which is the whole thing. We got to plug it in, substitute it in. So UM, that's 21 times 4 minus 13. That's going to be 84 minus 13, which is going to be 71. So 71. Here we have 10 times 4 plus 31, which also better be 71 because they're equal in length, right? They have a midpoint, so those two segments are congruent. Segment UM is congruent to segment MV. Therefore, UM is equal to MV, and 71 equals 71. To find UV, we simply add them together. So the whole thing is going to be 71 plus 71, which is going to be 142. All right, so UV 142. All right, let's look at number 7. Again, M is the midpoint, so we know DM equals ME. All right, we know segment DM is congruent to segment ME. So we know that DM is equal to ME. So 5x minus 6 equals 2x plus 5. Subtract 2x from both sides, add 6 to both sides. And then divide 3 on both sides. X is 11 thirds. At this point, you can just use your calculator. So 5, we want to find DE, so we need to find 5 times 11 thirds minus 6. We need to find 2 times 11 thirds plus 5. So that's going to be 55 over 3. We'll just put it in. 55 minus 6. Okay, so this is 37 over 3, and this is 37 over 3. So this is 37 over 3 and 37 over 3. We want to find DE, so 37 over 3 plus 37 over 3. That's going to be 74 over 3, which is just 74 over 3. Okay, so DE is going to be 74 over 3. All right, 8 through 11, we want to find the midpoint of these 2 points. They give us 2 points, and we're trying to find the midpoint. So to find the midpoint, we can just look at it. What's halfway between 6 and 10? It's 8. Okay, what's halfway between -3 and 5? That's going to be 1. So that's all we really need to do. But let's write out. Right, but let's write out our formulas. Okay, xm equals x1 plus x2 over 2, and ym equals y1 plus y2 over 2. Okay, so this is where we're at, running. So xm and ym are the values of the midpoint. That's what we're trying to solve for. This is going to be x1, y1. And this is going to be x2, y2. So the x values are 6 and 10. So we do xm equals 6 plus 10 divided by 2, which is going to give us 16 divided by 2, which is 8. The 2 y values are -3 and 5, so -3 plus 5 divided by 2, and that's going to give us 2 divided by 2, which is 1. So our midpoint here is going to be 8, comma 1. It's just an average. The midpoint is just the average. We're taking the average of the x coordinates and the average of the y coordinates. So again, here we'll make this x1, y1, and here's x2, y2. So our x values are 14 and -9. So 14 plus -9 divided by 2, that's going to give us 5 halves. And we also know ym equals x1 plus x2 over 2. I'm sorry, equals y1 plus y2 over 2. The 2 y coordinates are 7 and 1. So ym is going to be 7 plus 1 divided by 2, which is 4. 8 divided by 2, which is 4. So our coordinate here is going to be 5 halves, comma 4. Down here, same thing. This will be x1, y1, x2, y2. Here's our two midpoint formulas, one for the x value, one for the y value. We're just taking the average, so negative 13 plus 2. That's going to give us negative 11 over 2. Here we're taking the average, 8 plus negative 10. It's going to be negative 1. So we should have negative 11 halves, comma negative 1. Okay, and then here, our x values are negative 5 and negative 18. 2. That's going to be negative 23 over 2. Okay, down here we have negative 17 plus 12 over 2, which is going to be negative 5 halves. So our midpoint is going to be negative 23 over 2, comma, negative 5 over 2. And that is midpoint. Just taking the average. You can just eyeball it. What's between 6 and 10? 8. What's between negative 3 and 5? 1. What's between negative 13 and 2? 11, negative 11 and a half. That's negative 5, that's 7 and a half away from each one. Okay, what's between 8 and negative 10? That should be 1, negative 1. Okay, what's halfway through 7 and 1? 4. Halfway between 14 and 9? Negative 9, 2.5. Okay, so it's the average. All right, 12 through 15 wants us to find the other endpoint. So use the given endpoint R and midpoint M of RS to find the coordinates of the other endpoint. So just to visualize what we have here in number 12, I'm going to draw a little graph. It was green. Can you see green? Yeah, you can see green. Well enough. We have R is 8, 0. We have M is 4, negative 5. The question saying using given endpoint R and midpoint M of RS to find the coordinates of the other endpoint S. So here we're given 2 points, an endpoint, and so there are, let's see, we have an endpoint, we have a midpoint, and then we have another endpoint. Okay, we know one of the endpoints is R. Okay, we know the midpoint M is 4, negative 5, and we're looking for the other endpoint S. We're going to call it x2, y2. So S is the endpoint, which we're trying to find. So we have one endpoint, the middle, okay? So S is going to be somewhere down here. We don't know where exactly, but it's somewhere down here. X2, Y2. So we're going to use the exact same formulas as we did before. So XM equals X1 plus X2 over 2. And YM equals Y1 plus Y2 over 2. Taking the average of the X values, average of the Y values. We know what the X value of the midpoint is. We know it's 4. So this is going to be 4 equals the first endpoint. So this endpoint is X1, X2. X1, Y1. This is XM, YM. And this is X2, Y2. That's probably a little hard to see up there, though. So this is X1, Y1, XM, YM, X2, Y2. So we use our same two formulas here, except this time, unlike the midpoint, we know the midpoint. We know the midpoint is 4, negative 5. So we know 4 goes in, substitute in for XM, and negative 5 gets substituted in for YM. So this should be 4 equals, X1 is 8. We don't know X2. That's what we're solving for. Okay, over here, we know the midpoint. The y coordinate of the midpoint is -5. The y value we have is 0 and plus y2 over 2. Okay, we got to get x2 and y2 by themselves, so we need to multiply both sides. So for this one, if we can somehow separate these, we multiply by 2 on both sides. Okay, we're going to get 8 equals 8 plus x2. We subtract 8 from both sides. So then we get 0 equals x2. Multiply both sides by 2 over here. These cancel, so we get -10 equals 0 plus y2. So that's just -10 equals y2. So we know that our point S is going to be 0, -10, which is going to be down here somewhere. Okay. Let's try another one. I'm going to do it in different colors so we can see it better. So we have an endpoint, okay, and a midpoint. We're trying to find the other endpoint. Okay, this is going to be x1, y1. This is going to be xm, ym. This is going to be x2, y2. Okay, we know the first endpoint. We know it's 7, -17. So we know r is 7, -17. We know the midpoint. The midpoint is m. So -m is -2, 3. And what we're looking for is s. And we don't know s, so we'll call it x2, y2. That's what we're solving for. We're solving for x2 and y2. So let's use our equations. Xm equals x1 plus x2 over 2. Okay, so xm is the midpoint, the x-coordinate of the midpoint, which is -2. We know that x1 is the x-coordinate of the midpoint that they're giving us. So that's 7. And x2 is what we are solving for. Okay, so plus x2. Okay, we multiply both sides by 2. We get -4 equals 7 plus x2. Subtract 7 from both sides, we get -11 equals x2. So the x-coordinate of our other endpoint is -11. Now we need to find the y-coordinate. So we use the average or the midpoint formula for the y-coordinate, which is y1 plus y2 over 2. We know the midpoint is 3. The y-coordinate of the midpoint is 3. We know the y-coordinate of the endpoint that we're given is -17. And we don't know what y2 is. Multiply both sides by 2. Okay, we get 6 equals -17 plus y2. Add 17 to both sides, we get 23 equals y2. So we know our other endpoint is going to be -11, comma 23. Okay, we can check and see if that makes sense. So 7, -17 is down here. -2, 3 is here, and -11, 23 is over here somewhere. So it looks like it's pretty good. Although, yeah. Yep, looks good. I'm sorry. Okay. Didn't look good because this is -2, 3. So here's our midpoint. Here's our new one. Right. Here's M. Here's R. And here's S. I hope that's straightforward. This is the level 4 question for midpoint and distance. All right, 14. Let's do it again. Okay, so xm equals x1 plus x2 over 2. And ym equals y1 plus y2 over 2. So xm, the midpoint here is 8, the x value of the midpoint. And then the x value of the endpoint they're giving us is -6, and we need to find the x value of the other endpoint. So x2. Multiply both sides by 2. That's going to be 16 equals negative 6 plus x2. Add 6. 22 equals x2. Now we need to find the y coordinate. So the y value of the midpoint is negative 5.5. So negative, let's do it down here. Negative 5.5 equals the y value of the endpoint that we have is negative 9. And we're looking for the y value of the other endpoint s. Multiply both sides by 2. Okay, so that's going to be negative 11 equals negative 9 plus y2. Add 9 to both sides, and negative 2 equals y2. So our other endpoint s is going to be 22 comma negative 2. We can check and see if it's going to work. So we have negative 6, negative 9, that's going to be r. 8, negative 5.5 is m. 22, negative 2 is over here. So that looks like it's pretty good. $15. So again, let's write our equations. Xm equals x1 plus x2 over 2, and ym equals y1 plus y2 over 2. So the x value of our midpoint is negative 3.5. So again, if we have a graph, let me do it over here. Here's our graph. 11, negative 16 is down here, that's r. M is negative 3.5, negative 9.5, which is going to be down here somewhere. So M is the midpoint R, which means S is going to be somewhere over here. So it better be negative and then slightly negative. Right, so the x coordinate of R is going to be 11. We don't know the x coordinate of S, so that's just x2. We multiply both sides by 2. So we're going to get negative 7 equals 11 plus x2. Minus 11 from both sides, that's negative 18 equals x2. That one looks like it's pretty good. Let's find the y value though. So the y value of the midpoint is negative 9.5. A y value that we have is negative 16 for the endpoint, plus y2 divided by 2. You multiply both sides by 2. That's negative 19 equals negative 16 plus y2. Add 16. Both sides, negative 3 equals y2, so our coordinate is negative. Okay, and that makes sense. That looks like it's negative 18. We're already at 28 minutes. Wow. All right. That's why we did this over 3 days and not just in one, right? All right, the length of the segment. So here we're using the distance formula to find the length of these segments. So our distance formula is the square root. Okay, the change in x squared plus the change in y squared. So x2 minus x1 squared plus y2 minus y1 squared. So change in x squared plus change in y squared. Our 2 points here are A, 1, 2, and B, 7, 4. So we're finding the distance between those two. The two x values are 1 and 7. So D, this was the problem. We're doing 16 first. Okay, so D, the x2 and x1 are going to be 7 and 1. It doesn't matter which order you put them in, because 7 minus 1 squared is the same as 1 minus 7 squared, because the negative becomes a positive when you square it. Okay, so 7 minus 1 squared plus, and our y values here are 4 and 2. So 4 minus 2. Okay, from here you can just put it in the calculator, come up with an answer, or we can keep it in as a radical. That's going to be 7 minus 1 is 6, so we have 6 squared, plus 4 minus 2 is 2. Okay, 6 times 6 is 36, plus 4. Okay, square root of 40. We can leave it there. We can put it as a decimal. Either one's fine. This is saying round to the nearest tenth, but that's okay. We can also reduce our radical, simplest radical form. That's 4 times 10, which is going to be square root of 4 is 2, and then you have square root of 10 left, 2 root 10. Okay, or approximately 6.3. Okay. All right, let's do 17. Okay, so our points here are G negative 3, 2, and H 3, negative 3. Distance formula. The square root of change in x squared plus the change in y squared. Okay, we use the Pythagorean theorem. The distance formula is the Pythagorean theorem. It's just rewritten. Okay. The x values here are 3 and negative 3. We want to make sure our negative stays the same. Our subtraction side stays there. So let's do 3 minus negative 3. Our y's are negative 3 and 2. So let's do negative 3 minus 2. So plus. Make sure you bring everything down. Negative 3 minus 2 squared. From there, you can put it in the calculator. That's fine. 3 minus a negative 3, though, is a 6. Negative 3 minus 2 is going to be a negative 5. 6 squared is 36. Negative 5 squared is 25. And then 36 plus 25 is 46, 56, 61. Okay, which is about 7.8, I believe. 8 times 8 is 64, so it's slightly, I'll just put it in the calculator to make sure. Square root of 61, 7.8. Okay. Let's do the next one. 18, so we have our distance formula. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, the two x values here are negative 2 and 5. Doesn't matter which order you put them in, negative 2 minus 5 or 5 minus negative 2. So we have 5 minus negative 2 squared plus the two y values, negative 4 minus 0 squared. Okay. And from there, you can just put that in the calculator. That's fine. Get an answer, get a decimal, round it to the nearest tenth. But if you want to reduce our radical, we have square root of 5 minus negative 2 is 7. Negative 4 minus 0 is negative 4. 7 squared is 49. Negative 4 squared is positive 16. That's going to give us 65, which is 8.1, approximately 8.1. About 8.1. 19. Okay, our 2 points here are n, negative 1, 2, and m, negative 4, negative 4. So our distance formula is square root of the change in x squared plus the change in y squared. The two x values are negative 1 and negative 4. Negative 1 minus negative 4, right? Negative 1 minus a negative 4 plus negative 4 minus 2 squared. That's going to give us negative 1 minus a negative 4 becomes a positive 3, so that's 3 squared plus negative 6 squared, which is going to be 9 plus 36, which is going to be the square root of 45, which is approximately 6.6 something. I don't know, 6.8, 6.7, probably 6.8. Square root 45 is 6.7. Okay, that's distance formula. Let's scroll down to the next section, 20 through 23. Find the length of the segment, then find the coordinate of the midpoint. So let's start first with 20. Okay, you want to find the length of the segment, JK. Two ways to do this. The first way is we can just simply count 2, 4, 6, 8, 10, 12, 14, 16. Look at that, it's 16 units long. Or we can take the absolute value of the difference. So JK is going to equal the absolute value of this. And so this is negative 14. Difference means subtract. So we do negative 14 minus 2, or we can do 2 minus a negative 14. Either way, we're going to get the absolute value. We're going to get 16 when we take the absolute value and get a positive. So JK equals 16. The other question here is asking for the midpoint. So we're doing 20 right now. I'm going to do it over. I'm going to do it down here though. Okay, so this is the distance. So this is distance. Now we need to do the midpoint. Okay. So midpoint is average. So we're just taking the average of the 2 points. So our 2 points are negative. Our 2 endpoints are negative 14 and 2. So negative 14 plus 2 divided by 2. And that's going to be negative 6. So our midpoint M is negative 6. Take the average. And 2 endpoints, add them together, divide by 2. Here we took the absolute value of the difference. Difference meaning subtraction. Okay, or just count. Just count how far apart they are. All right, let's look at 21. Okay, so PQ. Okay, we can just count 5, 10, 15, 20, 25, 30, 35, 40, 45. It's 45 units long. Or we can take the absolute value of the difference. And the absolute value of the difference is going to be negative 30 minus 15, which is going to be 45, right? Negative 45, but you take the absolute value, and that gives you a positive 45. To find the midpoint, we take 2 pieces, so negative 30 plus 15, and we divide by 2, and that's going to give us negative 15 over 2, which is negative 7.5. So here, midpoint is right here. Probably put M equals midpoint. Okay, down here we have, it doesn't give us the coordinates, but our distance, I'll put D for distance. It's going to be the absolute value of negative 3 minus 6, which is going to be negative 9, but absolute value makes it positive. So the length here is 9. Okay. The midpoint is the average. So we'll take negative 3 plus 6 and divide by 2, and that's going to be 3 over 2, which is 1.5. So our midpoint is right here. Three and a half. Over here, absolute value, you can count 1, 2, 3, 4, 5, 6, 7, or we can take absolute value of negative 8 minus a negative 1. So that's negative 8 plus 1, which is negative 7, which is 7. There's our distance. Midpoint, negative 8 plus negative 1 divided by 2. That's going to be negative 9 halves, which is negative 4.5, which is right. Right, in the midpoint, the coordinate of the midpoint, there's only one coordinate. Because it's the line, and lines are one-dimensional, so each point on the line only has one coordinate. What are we at? 40 minutes already? It's all right, this was a 3-day thing, so it's okay. The next three are just like 5 through 8. So in the diagram, M is the midpoint of the segment. Find the indicated length. Since M is the midpoint, we know segment LM is congruent to, right? Segment LM is congruent to segment MM. Therefore, we know LM equals MN. The length of LM equals the length of MN. That's the definition of congruent segments. LM is x plus 9. MN is 4x. We can subtract x from both sides. And then we can divide by 3 on both sides. And we get x equals 3. Our goal, though, is to find Ln. So we need to substitute this back in for x. So we're going to get 3 plus 9. Right, 3 plus 9 is 12. And 4 times 3 is 12. So we have 12 plus 12 is Ln is 12 plus 12, which is 24. Over here, again, M is the midpoint, so we know that segment AM is congruent to segment MC. So we know that the length of AM equals the length of MC. AM is x plus 20. MC is 5x minus 4. We subtract x. 20 equals 4x minus 4. We add 4. We get 24 equals 4x. We divide by 4. And we get 6 equals x. We are looking for AM. So all we do here is substitute it in for x. So 6 plus 20 is going to give us 26. AM is 26. The next one, M is the midpoint once again. So we know that segment PM is congruent to segment MR. So we know that PM equals MR. So we know that 4x minus 12 equals negative 2x plus 21. I would add 2x to both sides. That's 6x minus 12 equals 21. We can add 12 to both sides. 6x equals 33. Divide by 6. X equals 33 over 6. From there, we can just use our calculator. MR equals negative 2. Substitute in for x. So negative 2 times 33 over 6. And then plus 21. So we can just put that in our calculator if we want to. Although negative 2 divided by 6 is going to be, that's going to leave a 3 in the bottom. So that's going to be negative 11. So our answer is going to be 10. So MR is going to equal 10. Okay. The last section here is 27, 28, 29, 30. We want to find the following points. There's a graph to help you, but you must show your work. Find the distance of the point. Again, I don't really care if you leave it in radical form or if you put it as a decimal. So let's just find the distance between the points. And then we want to find the midpoint. So distance here for 27 is the square root of the change in x, x2 minus x1, plus the change in y squared. The two x coordinates are 2 and 4. So distance square root 2 minus 4 squared plus the two y values are 3 minus negative 3. So 3 minus a negative 3 squared. Okay, put that in your calculator and get an answer. But if we leave it here to get it as a radical, we're going to get negative 2 squared plus 6 squared, which is going to be 4 plus 36, which is going to be 40. Okay, which is also going to be 4 times 10. So 2 roots 10. Okay, this is 427. Okay, then we want to find the midpoint. So xm is going to equal x1 plus x2 over 2. And ym is going to equal, let's do it over here. Ym is going to equal y1 plus y2 over 2. Okay, the two x values here are 2 and 4. 2 plus 4 divided by 2. We're just finding the average, and that's going to be 3. The y values are 3 and negative 3. 3 plus a negative 3 over 2, that's going to be 0. So our midpoint is 3, 0. Okay, that makes sense because 3 is between 2 and 4, and 0 is between 3 and negative 3. So that's 27. Let's look at 28. So 28, our distance formula is the square root of the change in x squared, or x2 minus x1 squared, plus the change in y squared, y2 minus y1 squared. The two x coordinates are 5 and 1, so 5 minus 1 squared. You do 1 minus 5, that's fine too. And then your two y values are negative 3 and 6, so negative 3 minus 6 squared. So our distance here is going to be 4 squared plus the square root of 4 squared plus negative 9 squared. So that's 16 plus 81, which is 87, 97, square root of 97. Okay, midpoint, so xm equals x1 plus x2 over 2. So xm is going to equal 5 plus 1 divided by 2, which is 3, and that makes sense because 3 is between those 2 points. And then ym equals y1 plus y2 over 2. So ym is going to be negative 3 plus 6 over 2, which is going to be 3 halves. So our midpoint is going to be 3, 3 halves. Let's do 29. So distance formula is the change in x, so x2 minus x1 squared, plus the change in y squared, so y2 minus y1 squared. So the two x values here are 2 and 4. So 2 minus 4 squared plus your two y values, which are 6 and negative 5. So 6 minus a negative 5 squared. That's going to leave you with negative 2 squared plus 6 minus a negative 5 is 11. Right, negative 2 negatives make a positive. So we have negative 2 times negative 2 is 4 plus 121. So that's going to be square root of 125, which is fine. You can leave that, or you can break it down. That's the square root of 25 times 5, which is going to be 5 times the square root of 5. Find the midpoint, xm. So we take the average. It's just going to be 3. Do we really need to do it? 2 plus 4 is 6. 6 divided by 2 is 3, but let's write it out. 2 plus 4 divided by 2 is going to give us 3. Ym y1 plus y2 over 2. That's just going to be 6 plus negative 5 divided by 2, which is going to be a half. Right? 6 plus negative 5 divided by 2 is going to be 1 over 2, which means our midpoint is 3, 1/2. Okay, let's do the last one here. Okay, distance, square root, x2 minus x1 squared plus y2 minus y1 squared. 2x, again, this is going to be, so we just know the midpoint, right? The midpoint, okay, come on, let's do it out. So distance is 8 minus 6 of the two x values. The two x coordinates, two y coordinates are negative 2 and negative 4. So minus negative 4 squared.
Yeah, I'll come back.
Okay, that's fine. Either way, okay. All right. Okay. So we have 8 minus 6 is going to give us 2. Okay, and then negative 2 minus the negative 4 is negative 2 plus 4, which is going to give us 2. So we have 4 plus 4, which is going to give us square root of 8. Okay. Okay, which is going to give us 2 root 2. Okay, and then midpoint. So again, xm equals, well, we can see. What's halfway between 8 and 6? It's going to be 7, right? Between negative 2 and negative 4 is negative. Okay, so that is measuring segments day 2. Okay, everything on there. If you can do everything on there, should be good.